All right, when you're ready to begin the posterize function, you're going to need to figure out how you're going to group these pixels. Because essentially, you're going to need to get these pixels grouped into 4 clusters. We need to base that on intensity, and then recolor those clusters one of these 4 Shepherd Fairy color palette colors. Right? I think it's going to look the best if you use the darkest intensity regions in your grayscale image and color those using your darkest color in your color palette. Right? If you look at the code that you start with for the posterize function, it looks a little different than the other functions because you're not only going to pass an image into this function, you're also going to pass in the 4 colors for your chosen color palette. Okay, so make sure you pass in all 5 of these things as arguments when you call posterize. Now you can pass in the Shepherd Fairy color palette if you want. That's provided for you, but you can certainly do other color palettes if you so choose. Right, so that's up to you, right? Whatever you decide. When you do decide how you want to do that, you're going to have to do the grouping, right? And I'm going to share with you a little bit about how I would like you to do that grouping. So let's go over to a blank slide. Right. All right, and let's walk through this a little bit, how this grouping is going to work. Right, so we know already that the image is going to be grayscale. Right? You're already going to have applied the grayscale effect to your image, and each pixel in your image should just have one value for each color channel, right, which is going to be the average intensity of each pixel. So in theory, we could have a pixel, although we don't know this yet, but we could have a pixel at the very darkest region of the range of possible values, and then going all the way up to the lightest value. Right? We know those values are 0 for the darkest potential pixel, and then the very lightest potential pixel could be 255. Okay. Now for the Shepherd Fairy effect, basically what we want to think about is, well, going from dark to light, we want to group these into regions. So we're basically going to have some cutoff points that we're going to say, we're going to break it into 4 equal subregions or subranges. Right. So for example, 0 going up until this breakpoint is going to be your darkest color region. Right. So pixels from 0 to whatever this value is are going to be recolored using the darkest color in your color palette. Right, and then you're going to use the lighter colors for each of the 4 subranges going up all the way to the lightest would be whatever you have, whatever this breakpoint is, up to 255 are going to be the very light, whatever the lightest color in your color palette is, right? And then you're obviously going to have these other regions as well. So you're going to have this one and this one, all right, with another breakpoint in here. And that's, you just have to do a little bit of math to figure out what these regions are going to be, what these breakpoints are going to be, so you can group these pixels accordingly. Okay, now that's all you have to do. As an extension, what you can think about is, well, what if we can narrow these regions? Maybe I don't have this 0 intensity, this very darkest pixel in my picture, or maybe I don't really even have this lightest pixel value in my picture. So if you don't have either of those, there's no need to include those as part of your range. You could narrow your range and make your subregions more accurate and potentially get a better Shepherd Fairy effect picture. So rather than 0, what you could do is you could figure out the smallest value in your photo. You could do that by running a minimum algorithm or a min algorithm to figure out what that min value is for your photo, and replace the min with the 0, right? And you could do the same for the max. You could write a max algorithm, figure out, well, what actually is the maximum pixel value, and you could replace it with this. If you replace that, let's say rather than 0, let's say you found out the min was 5, and maybe you found out rather than 255, your max was like 240, maybe, right? That's going to narrow these ranges and it's going to shift these ranges around. So when you find these equal subregions, you're going to shift things around a little bit and your picture is going to look a little different. So this is going to be the extension, the min algorithm and the max algorithm, right? As a cool extension to this project.